Okay, so here, just to check that we know what's going on, can we use, on slide 10, can we use the identities above to show that sine of 2x is identical to 2 sine x cos x? Show that cos 2x is identical to cos squared x minus sine squared x, and also prove that tan 2x is identical to 2 tan x all over 1 minus tan squared x. And then if you manage to do those, from this identity, could you prove that cos squared x is identical to a half plus a half cos 2x? And can you also prove that sine squared x is identical to a half minus a half cos 2x? So you can discuss amongst you two. If you, in fact, I probably encourage that you do that because you might be able to get somewhere between the two of you. I'm going to be silent for 3 minutes and I'm going to let you have a go. Maybe you can discuss between you two as well. Is that okay?
Yeah.
Cool.
Yeah. And for the first one, you'd use the sine a plus b,
Yeah.
and then it'd be x plus x, sine x plus x. And then when you put it in the formula, you get sine x cos x plus cos x sine x.
Yeah.
Oh no, wait a minute. Oh, and then sine x cos x plus cos x sine x would just be 2 sine x cos x.
For which one?
For the first one, sine x cos x plus cos x sine x would equal 2 sine x cos x, right?
Oh, yeah.
And then for cos 2x, do you want to do the next one?
Yeah, sure. If you as like the arrows say, if you make them equal to half x, sorry, half plus half cos x, cos 2x, and half plus half minus half cos x.
Sorry?
Sorry, I'm just thinking. One second.
Alright.
I'm not really sure how to do the second one.
Sorry?
Not really sure how to do the second one.
The second one, so in the brackets you put cos x plus x, and then in the equation it would be, you'd expand it to get cos x take away sine x, and then because you times them by each other, they become cos squared x take away sine squared x.
Oh yeah, okay. Thank you.
Awesome. That sounds good. And it was a bit more than 3 minutes that I was out, but it's fine. In terms of using those identities, using specifically the fact that cos 2x is cos squared x minus sine squared x, could you then go on to prove that cos squared x is a half plus a half cos 2x, and that sine squared x is a half minus a half cos 2x? Again, I'll give you 1 minute, and then I'll go through answers. Okay, it's been about a minute. Is it okay if I go through answers, or do you want me to hold back for like another 30 seconds?
Yeah, go for answers.
Yeah.
Okay, so I heard discussions and stuff. So yeah, for sine 2x, by rewriting it as sine of x plus x, you get sine x cos x plus cos x sine x as per the identity. And that simplifies to 2 sine x cos x. Equally with cos 2x, we again say that's the same thing as cos of x plus x, which is cos x minus sine x, which again simplifies to cos squared x minus sine squared x. We'll come back to that identity because we're going to use it for proving the other stuff. Let's go to tan. So tan 2x, again, same thing. We say it's tan of x plus x, which is identical to tan x plus tan x using the identity that we know from here. Tan a plus tan b over 1 minus tan a tan b. So tan x plus tan x over 1 minus tan x times tan x. And that's going to be 2 tan x all divided by 1 minus tan squared x. Cool. And then if we use the fact that cos 2x on the next slide is the same thing as cos squared x minus sine squared x, we can say cos 2x is the same thing as cos squared x. We can write it as 1 minus sine squared x. So 1 minus sine squared x minus sine squared x. So I get cos of 2x is equal to 1 minus 2 sine squared x. Adding the 2 sine squared x to both sides and taking away cos 2x, I get 2 sine squared x is equal to 1 minus cos of 2x. So I get sine squared x is a half minus a half cos 2x. So that's one of the identities that we were asked to prove that I wrote in red, which is over here. And the other one, that cos squared x is a half plus a half cos 2x, same kind of thing, except we're going to replace sine squared x with 1 minus cos squared x this time. So cos 2x is cos squared x. Rather than writing minus sine squared x, I'm going to put minus 1 minus cos squared x. So cos 2x is equal to cos squared x minus cos squared x is 2 cos squared x minus 1. And then getting the cos squared x by itself, I get cos 2x plus 1 equals 2 cos squared x. And then dividing by 2, I get a half cos 2x plus a half equals cos squared x. Or indeed, cos squared x is equal to a half plus a half cos 2x. All good?
Yeah.
Yeah.
Lovely stuff. So that's it.